Hello, everyone. I welcome you all to the Kubernetes Bangalore July 2020 meetup. It's great to see all of you joining us here on a weekend afternoon. So this meetup that we are doing this month is without a theme. So we will have two speakers who will be taking us through to different technologies, and I hope you engage with them in the comment section. They will be available for both here and on their social handles. So you can definitely, if you have any doubts or questions, or if you want to engage with them, you can engage with them there. Um, so without wasting too much time, since we are short on time, I think I can introduce you to the first speaker. So our first speaker for the day is Nuren. He goes by the handle of Your Tech Bud. So, so Nuren founded Space Up Tech, and they use Kubernetes and Istio mainly and extensively. So he will his talk will be around choosing the right service mesh for your needs. So yes, I'll be handing it over to Nuren. Over to you, Nuren.
Yeah, thanks. Thanks for introducing myself. Can you quickly just put up my presentation on the? Oh, perfect. That's wonderful. Yeah, thank you so much, guys, for getting me on board and having me over. I'm super thrilled, super excited because Kubernetes and service meshes in general is like a really close thing to me. So yeah, I go by the name Your Tech Bud in the community, but as my mom likes to call me, the real name is Nurain Panjwani. I'm the founder of a company called Space Up Technologies. And this talk, like the title slide mentions, we're going to go through the journey of choosing a service mesh. Now, I'm not sure if everybody is on the same page or regarding what a service mesh is, but a TLDR, a service mesh is like an entity which works in your system to secure communications between microservices and to control networking in general. I'm not gonna really get into how it works, but if you really want me to dive into that aspect, just drop a comment, right? I'm constantly monitoring that. So any questions of service mesh in general, just drop a comment and I'll pick that up. So the first thing is absolutely setting the context, right? Because whenever you're choosing any tech tool, it's really important to know what you want to do with it. So in my case, it's regarding the open source tool we've made, which is called Space Cloud, right? Now back then, Space Cloud used to be like an open source Firebase. So it's like creating GraphQL APIs on any database out there. And we were actively exploring adding a serverless component to it, and like a container as a service. I'm not sure if you're aware of it, like Google Run, like Cloud Run, or Fargate is like good examples of that. But we wanted to make it like Kubernetes based. And you might know that for such type of cloud native enabling tools, we really need a service mesh, because service mesh really powers this in terms of security and controlling the network. So yeah, in that context, we're gonna be doing it. And the idea was that the people who use Space Cloud, they're already using it to simplify things, right? So we wanted to abstract Kubernetes and Istio away as well to make it easier to use. So technically using that without being aware of the existence. Just to give you an example of traffic splitting, right? Like what am I saying? Splitting traffic between multiple versions of your service, like for A/B testing or canary deployments. So the goal is for like going from this, right? Like a config file, which looks scary sometimes, to this, which is just like a UI and a few clicks and you're done. Right? And this is actually an example of how we converted that particular piece in Istio to what we have now. So that's the idea of Space Cloud. So a lot of our needs are different, but I've made it a point that I try to highlight even the normal aspects of choosing a service mesh in this presentation. So let me know, if I'm heavily biased towards our use case or not in the comments. As I said, I'm looking at it. So let's start with the criteria, right? What did we want from this. So security is a given. Like if you're really using a service mesh, uh, security is one of the most important things. And I'll just add one more thing. Service mesh is more like a log management system. Like you might not think it's really important unless you really need it. So our selection criteria was most importantly flexibility, because since people are relying on us to consume their service mesh, we did not want to be restricted by it. So if somebody from the community asks for a feature, we should be able to deliver it. So basically, the service mesh needs to have that feature. Plus, it should be easy to use, because I know we are like automating a service mesh, but we have to maintain that code, right? So it needs to be easy to use. It should be maintainable. Another thing which we really wanted was a degree of control over it. So we really want to get down to the core components, and have some degree of control so that we can control behavior as per our client's requirement, because our clients are working on on-premise environments. They're even working outside Kubernetes in certain cases. So we wanted that degree of control as well. And of course, robustness, because service meshes are new. It's important that it works, right? You don't want it not working. And since it's new, the major tool for that is just by looking at who's using it. That was our metric for robustness. And another thing was metrics, because for having a container as a service, like especially you're scaling up from zero, right? You could have zero replicas and you're scaling up from there. You really want like good control over the metrics, or like the number of requests being handled by each service. So the ability to play around with metrics and make it easily accessible within the system itself was very important for us. So without further ado, I'm gonna dive straight in. The first one has to be Istio, right? So Istio is like one of the most popular service meshes out there, and many tools in the cloud native industry are actually built on top of it. A classic one is Knative, right, which does something similar to what Space Cloud kind of does in the deployment space, right? It's again built on Istio. So the brilliancy of Istio is that big names are backing it. You can see like Google, IBM, Lyft came together to bring like get us Istio, and to a fun fact, Envoy, the proxy which Istio uses, is actually built by Lyft, the team at Lyft, right? So there are some big names using it at great scales. So the robustness really just comes out of there, right? Because it's battle tested really well. So it's really feature rich. I think Istio is by far one of the most flexible service meshes out there in terms of features and functionality. It lets you do a lot of things which other service mesh do not. Probably because it was just early in the market. But yeah, it's. I think the service meshes which we compared, it by far had the most features in it. So I mean, yeah, it gets that. But with those features and with that complexity is a factor of brittleness, right? Which we focused on. I mean, which we faced. So the idea is like Kubernetes, Istio likes to break its config in multiple resources. For example, when you're deploying a service in Kubernetes, you're configuring a deployment, then you also need to configure a service, and then you need to make sure that the service is pointing to the deployment using a selector. Well, Istio just does that and makes it a little more complicated, because there are so many different pieces of resources you need to configure to achieve one single task. So if you move something, you change something, and you do not update the other resources which depend on it, things will break, and that's brittleness, right? It gets very difficult to debug in certain cases because of how many moving resources there are in Istio. And just because of that, to understand the relationship between services, and because there are so many knobs, the learning curve associated with Istio is one of the highest, especially as compared to the other service meshes which I'll be talking about. It is kind of intimidating to get into Istio if you're really new to service meshes in general, right? But I think once you get a hang of it, like Kubernetes, it becomes second nature. You just know things. It becomes intuitive to a certain extent. But that brittleness compared with so many knobs makes it a little challenging. But it's a plus side as well, because there are knobs for everything. Like you can configure right from configuring the sidecar directly to having a high level thing on a virtual service. So you can really decide to what degree do you want to control things inside of Istio. And I think it offers a ton of flexibility right there. So Istio, to sum it up, Really feature rich, little difficult to learn, might be difficult to maintain if you really don't understand how it interacts with each other, but backed by huge names. Yeah, that's Istio for you, right? Now, again, there were a lot more points when we went through this journey because we actually did this while evaluating different service meshes for Space Cloud. Um, but I'm just trying to trim it down, condense it for this particular presentation. And as even Prakash mentioned, like feel free to reach out on Twitter or just drop a comment. When you want to dig deeper. Yeah, so that's Istio for you. The second one is the CNCF Starboy LinkerD, right? LinkerD is a CNCF project. Istio doesn't belong to a foundation yet, and if I'm not wrong, they're trying to make their own foundation. If I'm not sure about it, but I think that's the news. But LinkerD is really under the CNCF banner, which speaks a lot about its dedication to open source, and that's why again big names are supporting it. Okay, now I know you might be thinking that for Istio I had three big names. But for LinkerD, I've just put two. Like, yeah, for Istio, there are three, but for LinkerD, there's just two. And no, I'm not skewed towards Istio or anything of that sort. But the logos of these companies are like so wide. Just look at them. They put the entire name in it. So it was very difficult for me to fit it in that tiny space which I have. Yeah, so there are only two logos here. But yeah, if you go on the LinkerD site, there are really big. There's Walmart, there's Ask.com. So there are big names backing LinkerD. And yeah, the company behind LinkerD, which actually got it out, was Buoyant. So LinkerD is a plug and play kind of a service mesh. You install it and you forget it. And it really does a very good job at that. In most cases, if you want to stick to the basics, you don't really need to configure anything in LinkerD. So that speaks for the ease of use part. But and it's got several smart defaults to cover it up, right? I mean, you can override some of the config, but the defaults are like really smart. And you might not want to change them in normal circumstances unless you want to do something fancy like canary deployments or imbibe certain DevOps practices. So it fits the bill really well. It's got great defaults. The features which it has make sense for most use cases. And the docs are amazing. If you go through the docs of LinkedIn, you won't get lost. That's a guarantee, right? The way they've organized it, they've kept it really simple. It's a little bit lengthy, but it's still navigatable, right? It's easy to go about it. But the problem we had with LinkedIn is that it's more of a black box. So LinkedIn uses its own proxy. They've built their own in Rust. Means we don't have Envoy anymore. So we don't have the documentation which comes with Envoy. We cannot pull the metrics directly because there's no docs for LinkedIn in that case for directly the proxy. It becomes very difficult, especially when you want to control more aspects like we need to do in Space Cloud, because we want to really deliver the features to the user in a transparent manner. So that's the deal with LinkerD, right? It's not that feature rich. It's got most of the things covered, really easy to use. But if you really want to tinker into the specifics, you might not expect all the features to be there, because an example, right? Like MTLS for TCP, it's not enabled by default in LinkerD. It still isn't. I mean, so yeah, that's one challenge, especially if you don't know what your requirements are and they're going to be added on the fly within a few months. That could be a challenge. So somebody just asked a question of what are the use cases of Istio, which is a really good question actually, right? And so I won't just limit it to Istio. I'm gonna extend it to all the service meshes out there. So a use case for a service mesh in general is security. For example, if there are microservices talking to each other or just monoliths, just depending on each other, you might want to secure them. You don't want any service to be able to talk to any service, especially if something gets compromised, right? So service mesh enforces that, who can talk to whom, which service can talk to whom on the network layer. So even if your pods or your deployments get compromised, they won't be able to do squat, right? They won't be able to talk to the other services because they did not have permission or access to do that. That is one of the major reasons why service meshes got a lot of popularity, that they involve cryptographic means of authentication for services on the network layer, which is really cool. Another thing is that service mesh kind of knows all the traffic going around. So you can bend the traffic as per your wishes. For example, a service is talking to another service. Let's say A is talking to B, and my B has multiple versions. I'm trying to deploy a new version for B. But now I don't want to sit and configure A every time that, there's a new version, send traffic to there. On the service mesh, I can just split that traffic. I can say, 90% of my traffic goes to version one, and the rest goes to B, or like you can split it down to even multiple versions. So makes it simpler. Yeah, adds a little bit of more hardware, like properly pointed out by Mosin. But I think it's worth the risk. So we can even see like when should we even use a service mesh for that matter. But I'll move on from LinkerD at this point. I hope I answered your question, Satish. The next one is Consul. Okay. Now, when we were working with Space Cloud, we had a heavy dependency on Consul as a service discovery and as a KV store. So for clustering, we were already using Consul, and that's the background to it. And the best part about Consul is that even though it works a little differently from other service meshes, but it's got so much more. Like it's a KV store. If you all have used etcd or Consul, it's a full-fledged KV store. It really helps in service discovery outside of Kubernetes as well, and it's got a pretty decent service mesh built into it. Like it's called Consul Connect. Uh, so that was the primary reason we picked up Consul, because we were already so invested in HashiCorp. And back at that time, we had not chosen Kubernetes yet. We were still deciding whether we want to use Nomad, whether we want to use Kubernetes. So Consul was a good contender. Another problem is that the Consul is a little, the Consul Connect feature is a little difficult to navigate. Okay. Like I know Istio has a bad reputation in navigation of docs, but Consul is even harder, right? I mean, it really works well if you're using it with Nomad because it natively integrates with it. But if you're doing something by itself, it becomes a little difficult to understand what config is doing what. And it's very minimalistic even in functionality. So you don't get all the features which you would expect, especially for traffic routing and things like that. Uh, and a question by Motion, like, do you need global load balancers for Istio? Actually, for any service mesh, you don't need load balancers. The primary purpose of service meshes is inside the cluster and not outside. So you're still free to decide what you want to do. And that applies to all the service meshes which I'm talking about here, right? You can switch out whether you want to use a load balancer, whether you want to use the ingress gateway and stuff like that. So just briefly going through all the service meshes I mentioned, Istio really had a ton of features, but very difficult to configure because there are so many knobs. LinkerD works out of the box, feels really great that it's working. But if you want to really get deep into it, it's going to be a slight struggle there. And Consul is very good with the HashiCorp stack, and its scope is well beyond a traditional service mesh, right? So yeah, we chose Istio. So the learning curve is a challenge for us as well. But if you understand, Space Cloud is trying to automate it, right? And somebody just mentioned that Istio doesn't have a dashboard and LinkerD has a good dashboard, which is a fair point. But in our use case, we were creating our own dashboard. Like Space Cloud is supposed to be the front end to configure all of this. So that dashboard thing wasn't a problem for us. And also because everything is hard coded, like your config you do on Space Cloud generates out those resources automatically. So you don't have to really worry about how to use Istio or LinkerD. The brittleness wasn't a big challenge for us as well once we've nailed it down ourselves, because it's all hard coded, it's all templated, right? So it works really well for us. But I understand that for everybody else, they don't like have a tool which automates configuration, like spitting out configuration of Istio or LinkerD, right? So for that, we've also I've gone ahead and set up like a good document, like a good basic pointers, actually not a document, a basic few pointers where you can use to evaluate what kind of a service mesh would you want to use. Okay, so use Istio when you want a lot from your service mesh, and you really have the team to back you up, right? Just because you know Istio really well doesn't mean that your team would be comfortable with it. And if you really want to use a lot of service mesh features within a couple of months itself, Istio is perhaps going to be a very important aspect. Okay, because I mean it's the only one with all the features right now. So you don't have to wait for the service mesh team to get around it. And somebody just mentioned canary deployments. I think Istio is the best fit for canary deployments just because of the flexibility it offers in there. Like you can't, like it's not just limited to splitting traffic, but you can even split traffic based on conditions and things like that. It's very powerful. So especially if you want to integrate DevOps practices directly into service mesh, which a lot of people are doing now, Istio is a really good choice. But again, the learning curve, so you should have the team to back you up. Uh, LinkerD is a very good option when you want the basic features of a service mesh, but don't really want to get into it. So you're like okay with the things which come out of the box for LinkerD. You don't really want to get into uh, understanding LinkerD, but you just want the basic advantages of a service mesh, like built-in security, automatic encryption of all internal or like intra-cluster traffic, all those cool things you want out of the box without configuring anything. LinkerD is really good. But again, for certain features, you might have to wait for quite a while before the LinkerD team actually delivers them. So be careful whether what your requirements are. If it's a lot, go for Istio. If it's not urgent, if you can wait out for a year or so for like the more integrate features or the more niche features, then LinkerD is probably better off just because it's so easy to maintain. Uh, Consul, I think I would suggest Consul only if you are using the HashiCorp stack, right? Like you're using Nomad and you're like comfortable with Nomad and Vault and Consul, like the HashiCorp stack. It works really well with those. Another reason for using Consul would be when you're using it outside of Kubernetes, right? Uh, so when you want to use Consul outside of Kubernetes, it works really well because Consul is universal. It doesn't really works just with like Kubernetes. But the other two, they rely really heavily on Kubernetes. You can use them outside, but it's a very difficult process to do it. It's not straightforward. But Consul really puts it in the docs. How could you use it outside as well? Uh, Okay, interesting question. What was the deal breaker for LinkedIn in Space Cloud, right? So I think I briefly even mentioned this. In Space Cloud, our major challenge is to simplify the service mesh directly. So we don't like while you can get down to the config, you don't want to like mention it directly. So Space Cloud should be able to expose all the feature a person might need or a client might need. So we don't know the features we want upfront. Uh, so just for the sake that our service mesh has got our backs covered, we chose Istio primarily because it's very feature rich, and we kind of agreed with the philosophy which Istio deals with the config in general. Yeah, so yeah, that's it. And yeah, service meshes will add some latencies, but it's like in a few milliseconds. It's like barely 10 milliseconds or 15 milliseconds. There are good benchmarks, you can just check out online. I think Istio's FAQ even has the latencies introduced by Istio itself. So you can definitely do that. And yeah, we do have demos for canary deployments with Space Cloud, not with Istio directly. Maybe if Prakash likes the way this talk is going, he can invite me for another talk in which we do that. But we have an interesting blog post which covers that as well. So maybe I'll share the resources later. Uh, but you know what? Enough of talking about the big three, right? Actually, the big two, because Consul is still like a more HashiCorp specific task. But I've got a bonus for you guys, just because Kubernetes has helped us so much. And the bonus is Kuma Mesh. If you don't know about Kuma Mesh, again, it's a service mesh. You should definitely check it out. Kuma Mesh is amazing, right? It's by the team which built Kong. So it's Kong HQ, if you've heard of that API gateway, and they've got into the service mesh market as well. But service mesh is, I mean, Kuma as a service mesh is so cool because it's universal. As in, it works really well. It works transparently inside Kubernetes. So, I can talk to a simple service directly and Kuma will just intercept traffic for me. But if you're working outside of Kubernetes, like on VMs or something of that sort, but still want service mesh functionalities without having to get into what each component is, Kuma has got you covered for that as well. So I think it's a good kid. It still needs some time to mature, and that's the only reason why we did not use it, because back then it was like very early. I think it was 0.3 or something. So we couldn't use it. But my heart really goes to Kuma, because I think it's really cool, because it covers both an API gateway as well and a service mesh. So it has both, because Kong is your API gateway, which is one of the most powerful API gateways out there, and Kuma is a decent service mesh as well. So if you're like an early adopter and willing to check out service meshes, you can really check out Kuma, because it's really really good. And very interesting question, which I loved, is should you use an API gateway or service mesh? And Kamesh really answered that they tackle different problems. But I like to just pick that up, because we face this question a lot, right? Because we are a default service mesh company. So if you use Space Cloud, you are using a service mesh by default, right? So that's a big stance. So how we like to see it, that they both go together, but the major misconception comes from the idea of whether services should talk directly to each other, or should they always go via an API gateway. Now there are pros and cons to both of them. A service mesh will force your policies, because it's intercepting all traffic. In an API gateway, if a service decides to talk to another service directly, the poor API gateway can't do anything, because you just bypassed it altogether, right? But a service mesh is really intercepting the traffic in order to bring out all the feature functionality. So even if a person tries to mess with the IP addresses directly, they won't be able to do it, because the service mesh is really on the network layer. Whereas an API gateway primarily works on the L7 layer. So a service will have to intentionally talk to an API gateway, and then you go from there. So it depends on your use case, right? You might need both, especially if you have a low latency or mission critical application where services need to talk to each other directly, or and you might need an API gateway just for ingress. I mean, but I'll give you a use case where you would use API gateways for even internal traffic. So, like in Space Cloud, we have a GraphQL layer which lets you do joins on the fly. So, in a microservice architecture, normal problem is that you're trying to query a database, but then you cannot touch every tables, because a separate microservice has access to that. So, how do you do a join now? So, you might want an API gateway which acts like your data layer, and you can submit your queries to that gateway, and that gateway would perform the joins in that case. So your service is not talking to the other service directly, but it's talking to a data layer, right, which is performing those aggregations or joins on various data sources and giving you back a consolidated result. But again, this is a very new field. People have very strong opinions and different opinions on how people should use a service mesh, or how they should use an API gateway, and it's constantly evolving. With Space Cloud, we have a very different take on how a service mesh works and an API gateway works. So my answer to that question would be very skewed towards how we use it. So yeah, Kamesh pointed out a point whether service mesh can intercept payload. It can. So if you notice in Istio specifically, it's whenever you deploy a service with Istio, it automatically sets up IP tables. So even if you're talking to another service directly, the IP tables are forwarding all traffic first to Envoy, which is your local proxy. So all the traffic has to pass through Envoy. I think you can bypass it. I'm not sure if you can, but by default, all traffic has to pass through Envoy. That's how Istio works in general, right? Even ingress traffic passes to Envoy. Even egress traffic passes to Envoy. So technically, your actual service can only be accessed via Envoy. But all of this is transparent to you. So you'll be talking to a normal service directly, like you would be using service dot namespace dot svc dot cluster dot local, but the traffic is actually flowing through the respective envoys of those services. And we do use this feature functionality, because traffic splitting primarily works on that basis, that Envoy intercepts it and breaks the traffic itself. Also, promoting HTTP traffic to HTTPS works in that way, that Envoy intercepts HTTP traffic, but it itself promotes it to HTTPS, right? And yeah, somebody pointed out that Istio has an Istio gateway as well, which can be used for rate limiting. Just to be clear, rate limiting is deprecated right now, so don't use it. Recently, they deprecated it. But yeah, Istio is very powerful. It covers a broad spectrum. Okay, as I said, it's really feature rich. But now you may be asking, and I'm probably even gonna shoot up because my slot is over. But you might be asking that I think these features sound cool, like supporting security, enforcing PKI authentication at the service level, encrypting all internal traffic splitting for candidate deployments, but you don't really want to get into service meshes or learn anything. Well, use Space Cloud. A shameless plug from me as well, because you did it, Suraj, so I'm just gonna do it as well. So yeah, as I said, Space Cloud abstracts the entire service mesh away from you. You don't really have to work with Kubernetes or service mesh, but that doesn't mean you don't have to use it. I mean, you do not have access to it. Obviously you have access to it, but Space Cloud just gives you like a UI and some opinionated defaults to like simplify canary deployments via UI. And as a plus side, it also gives you like a backend as a service, so you don't even have to write code. You can create APIs directly on your database and secure them using security rules. uh, that is it from my side. Thank you so much, guys, for being so patient and for being so interactive. I mean, I am surprised of how interactive it got, on YouTube. This is my first YouTube live session. If you have questions, which I couldn't answer, you have some other ones as well. You could hit me up on Twitter, right? Or you could just follow me on Twitter just to be up to date with, what we do, and, some general news about serverless in general. Or you could even hit me up on LinkedIn. My LinkedIn ID is right there. And if you like this presentation and if you think that it was helpful, and that, Space Cloud also is good, you like it, please give us a star on Space Cloud. I would really appreciate it. And yeah, why not? Give it a try as well. Yeah, thanks once again. Thanks, Prakash, for having me over. Thanks, Suraj, for having me over. Over to you guys.
Yes. Thank you so much, Nurain, for this amazing talk. I definitely learned a lot from this, and I'm sure the audience did too.
I hope.
If you have any more questions, you can engage with Nurain on Twitter, and also the Kubernetes Slack. I have put up the India specific channels over there, so Nurain, you can find all of us over there. You can shoot your questions there.
Yeah.
So I think we've overshot by a bit, and I'll introduce Kamesh. So just give me 1 minute. Yeah. So our next speaker is Kamesh. Kamesh works at Red Hat, and he's gonna be talking to us about an introduction to Knative project. So over to you, Kamesh. Uh, Kamesh, I think you're muted.
I'm sorry, I was mute.
Yeah.
So I was just muting. All right, so you could hear me well, right? So, and then my screen is also visible, I guess. Great. So thanks, Narun. I think it was a fantastic talk, and I learned some refresher around service mesh to see what all things happening around in that space. It's been some time since I just touched that. So all I'm going to do right now is to just share a very quick intro about a Knative, and then what we can do with Knative, like just to get yourself started if you want to start with. So before I get started into my slides and other stuff, if we have any questions on my session, so obviously I don't have a formal slides done. I think I'm going to reuse the slides which I use for my other streams. So this is more pretty much about myself. So I work as a director for developer experience at Red Hat, actively evangelizing on service mesh serverless technologies. Been a Java developer for quite a long time, and then I'm being an open source contributor for quite a few open source projects as well. So, and also, like, I'm happy to share that I got my book released a couple of months back. That's a Knative cookbook which is on serverless. I can grab a copy of the book. The link of the book is right there, and I'm also going to share the slide, and I'll request Prakash to post that on the Meetup page so that you can grab a copy of that. Let me see if I can put this on the chat as well. Let me go ahead and see if I can put that on the chat. I'll quickly put that. So let me put this here, https dn.dev/knative cookbook. That's the download link where you can grab a copy of that cookbook as well. And all the commands that I'm going to use as part of today's demo is going to be more demo for next 20 minutes, 25 minutes or so. So it's all available as part of the tutorial which I maintain. It's called dn.dev/knative tutorial. I'm putting that as well again on the chat. So don't worry if you miss my command. Please do ask questions. So let's discuss more. You can always find the commands back on the chat when you get the chat as well. So that's the place where you can find all the commands of what I'm going to type right now. And also, like, you can grab the copy of the slides. This slide is more like a kind of refresher if you want to go back. It's going to be dn.dev slash knative master, right? So that's going to be the slide link. I can grab the same slides which I'm right now using here as well. All right. With that, like, don't, as said earlier, like, if you want to ask any questions around this session, please do drop me a note. Follow me on a Twitter, DM me on Twitter or LinkedIn or GitHub, wherever you wish to. I also have my email ID there, so you can just drop me a note in case if you're interested to learn more about Knative, serverless, and how it all works. All right. So with that, what I want to quickly do is, like, I don't want to take much time on the slides. You can always go back to the slides to read more about the history and other stuff where you have the Knative. So I just put down some history as well, and why Knative and all of this stuff. You can just go watch that out on the chat. I mean the slides, so which will get you through that. I'm not going to go through that. Let me go quickly to how do we get these things installed, right? Installed and up and running. So as I told you, there are a bunch of resources for you. The slides, when you get to the slides, the resources slides has a links for that as well. You can go grab it. So one of the best ways, as I said earlier, so you can just go to GitHub, this particular GitHub one, the link which I pasted on the chat. So that's going to take you to the Red Hat Developer Demos Knative tutorial. So that's the one which I'm actively maintaining. Right now, I published the tutorial for 0.14. I think right now we have 0.16 as part of Knative thing. So let me make this a little bit bigger so that it's easy for you to see on the screen. So and then I'm going to update that soon. I'm just trying to keep up a little bit of pace between the upstream release because upstream is doing super fast, right? And as I told earlier, so if I can click on this link, the link is going to take you to the tutorial. So this is the candidate tutorial which I'm talking about. So which I continuously maintain with the releases of Knative. It has all the stuff starting from deploy, how do you set up Knative locally on your platform, and on OpenShift. I'm going to show you OpenShift demos, but you can also run all these exercises and tutorials inside your local laptop if you have a Minikube or a Kind cluster running. So all these instructions are here, and then we'll be seeing about few of these examples about how do you create your first serverless service and all other stuff, and then about something about eventing and some advanced concepts as well, right, on camel key and other stuff. So I don't think so I have time to cover all these stuff. I'll just touch upon serving, and we'll show you some amount of auto scaling plus traffic distribution. And if I'm still with time, I'll show you something related to eventing. I quickly can show you eventing as well, right? So I have already done the setup considering the time we have. So how do you do a setup? This is my OpenShift cluster running on Google Cloud. This OpenShift 4. As you already know that these things can be installed using operators. So I used the OpenShift serverless operator. If you go to operator hub and then do serverless, you should get the or even type knative on the operator hub. This is the pretty much same thing as you see in an operator hub. You can go to operator hub. I'm just opening the operator hub as well so that, like, you know the similarities. So there is no big difference between these two things. This is just a console inside a console. We have bought an operator hub here, so you can see the operator hub screen as well. And then you can just go and then I click on the serverless operator, which is right here. Click on that. I've already installed this. That's the reason you see the uninstall operation. Just follow the wizard and you should have OpenShift serverless or Knative up and running in your cluster, in your Kubernetes cluster. In this case, in my case, it's an OpenShift cluster. And then you also have a lot of other stuff which gets installed, but let's not consider about that. This is a very simple thing. Go to the operator hub, search for Knative. Once you have Knative up on there, and then click on the install, and then you should have the thing installed there as well. I think let me go do the same thing here as well. I can do a Knative. You should see the Knative serving operator, eventing operator, and all of the stuff. You can just click on this. It will give you, when you click install, that should give you all the instructions to get started and deploy things on your cluster, right? This is on 0.13 version. What I'm going to show you is 0.14 version of Knative. All right. So, but what basically is Knative is, right? So, just to give a quick gist about what Knative can do, I'm going to take one little slide of this that can help you to understand the interesting capabilities. If you're aware of Kubernetes, you know that we can go from minimum is always one pod which keeps running always, unless and until I go and scale it down. But what with Knative we can do is like we can automatically scale up and scale down based on the traffic, which means that when it scales to 0, there is no pod, no memory. And when it scales from a spike up, and whenever there is a sudden traffic spike happens, it can go from 0 to any number of things. We'll see both of these scenarios during the demonstrations. It will also have the configuration and revisions built in. As Naren said, there are multiple service meshes that can be integrated. And in fact, Knative serverless does not need a service mesh. It just needs an ingress gateway. So we have multiple ingress gateway. If you go to the Knative doc, this is the Knative official Knative doc. I'm just going to put this also on the chat. Um, Let me, I think I'll come back to the questions in few seconds. Like I'll just finish my demo and then come back here. And then this one gives you status about installation, multiple ingress gateways that you can install. You can do Contour, you can do Istio, and I'm using Courier. It's another gateway, which is the simplest super fast gateway that I'm using within OpenShift. That's what I'm going to use here in today's thing as well, right? But you'll not see much about gateway. Gateway is all going to be behind the scenes. But coming back to the concept, it helps you to do the in-cluster traffic splitting, other stuff. That's what the ingress gateway and how the traffic gets inside. And you'll also see about Tecton. I'm not going to talk about Tecton here. And also an eventing system where it not only that you can give a call to Knative service, it can also be triggered by an event, right? You'll see a simple example of cron job during our demonstrations as well. So and with respect to configurations and revisions, that this basically what it does is like it adheres to the 12-factor application principles, meaning to say like any new change to your configuration, there will be a new deployment that gets triggered. Okay. So these are the super interesting capabilities. You'll see one of these demos and I'll see how much I can show in next 15, 20 minutes that I have. Prakash, please stop me whenever I'm go overboard so that I don't take anybody's precious time out. So let's go here and then quickly go to my demo project. This is a new thing in OpenShift 4. Like I have a exclusive developer console where I can do just developer-centric stuff. So to get started, what I can do, I can click on the container image on the landing page of OpenShift. If you go to the tutorial, the Knative tutorial, I have the vanilla Kubernetes examples as well. But just considering the time, I'm going to start with the deploying the container image right away. I'm just going to go here and then say query.io. That's the registry I'm going to use. I use RS developers slash eventing hello. So this is going to be one example which I'm going to use. I'm going to show you eventing later. So I just use the same service. So this is going to take an eventing app. Probably they should complain me because I already have the image stream available. So that's going to say eventing hello. That's going to be the application name. So let me go and delete the eventing stuff, right? OC delete is eventing hello. So that it does not complain me when I create. So with this console, what I can do is like I can create multiple stuff with OpenShift 4.5. Deployment became default, so there's no more deployment config. It becomes optional right now. If you want to do anything OpenShift specific object, which literally means that anything you deploy on Kubernetes is going to work here as well. All right. So I have this application. This looks good to me, and then I'm going to click deploy. And now you should see that my Knative service is going to come here, right? You see this KSVC, which stands for Knative service. That's going to come up, and then it's going to give you the service. Let's give you time. I think it's up and running for us right now. You see this here. So I have an URL route automatically created as well. So I can just click on this route, open the service. That's going to go you. It's a very simple hello world application. Nothing more than that. So I think if I remember correctly, so let's go back here. And then if I wait for some time, right, basically the default time, which is configured as 60 seconds, if I'm going to wait for 60 seconds, then what happens is that this service is going to go down automatically, right? So while that happens, so what I'm going to do is I'm just going to deploy a bunch of application to show you the traffic splitting version of that. So let me go and do a deployment here. This is called my blue-green canary example. I'm just going to go blue, right? So, and then I'll also do a quick open up of a small window here so that I can show these one side by side. New window, that's going to be smaller one because it's just going to show the color change, nothing more than that. All right, so let's wait for this service to come up. It will take a bit of time for the service to come up, and let's keep, okay, you see this here, sorry that, see this, the service is getting terminated here because it's not being used for quite some time. That's the reason why this service got terminated. And now when I click on the service again, go to the URL which we had earlier. So let me allow this to terminate again. And then when I go and get this back from here, do a refresh of this browser again, you should see the service coming up to life again. So you see the light blue color, and then this is going to go up and running again, right? You have another deployment coming up and running there. Okay, so that's how, like, what happens, it automatically scales down, and then that's going to give you resource cost or saving of any other thing that is might be required for you as well, right? Typically on the cloud scenarios. All right, so that's a very quick introduction about how do you get started with Knative deploying your very first service. This is not a function as a service. This is a typical microservice, which means that I can deploy any microservice workload onto Knative on top of Kubernetes as part of my serverless thing. Okay. Um, and that's with that thing. I think I'm going to watch. Come back to the questions and the chat. There's something interesting going on. And then this is going to be and then what we can also do is, like, when you go back here and then do this particular service which I already have. I got this one right here. I'm just going to open that up in my little window which is here, so that I can show you the service coming up right now. This is not going to do any big thing. So this is just going to show you the blue green canary demo which I already have. So this is going to be the blue one which is deployed right now on this particular service. That's the first revision which I have. If you just keep monitoring this revision, this is going to be the first revision which is deployed right now, which is going to be blue. What I'm going to do right now is I'm just going to go ahead and then do a green, and then say change the color to green right now. And if you go back to the console again, you should see one more deployment running up, the two which you saw here right now. And then all the traffic is now split into green color, right? Just to show a difference, I'm just using the colors here. All right. And as I said earlier, this one of the big advantages of using serverless is that, with especially with Knative, it adheres to 12-factor principles, which means that I just changed. If you see the earlier example, let me go on to my screen and show you. What I did is, like, I just changed two environment variables, which essentially means that I'm changing the configuration. Since it's a config change, basically there needs to be a deployment or a new revision created, so that at any given point of time I can go back to the last known code configuration. All right, so that's what Knative inherently does. That's the reason why you see a new deployment coming up and showing on the screen for you, which is like something like hxf something like -2, right? Just you can just monitor 1 and 2 and all these stuff. All right. And then what also we can do is, like, I'm just going to do one last thing again. So just to go and change this one to green, and that's what I'm going to do right now. And yellow, so this is going to change yellow right now in a second. So I'm going to have the third revision coming up right now, so which is going to change to yellow. And I have three revisions of Knative service here. Let me pull this up here so that you can see all these three things here. And then if you have three revisions of Knative up there, right? So let me see. Let me pause for a second and see what all questions is going around there. Um, All right. So what we can do right now is that we can just go back and then start distributing traffic. Let's say I don't like the BGC thing right here, and I want to go back to the blue color again. So let me go back here and then say blue here, and then save this one back. And now you should see the traffic splitting now happening to blue. The blue is coming up right here, and then all your traffic is now going to split to blue, right? And this is what I meant by, if you have revisions, I can go back to the revision and do last known good configuration and then start doing stuff. And then I can also do another one. I can go to yellow. Let's for green. If you want to do go for green, I can just do the green. The same thing like what I shifted traffic to blue. I'm shifting the traffic to green right now. We should have all the green right here. And then what I can also do is, like, I can also do as a candy, right? I can also do a candy kind of thing. I'm going to say 33%. I'm going to say to blue. Let me put this like this way. And then I'm going to say 33% green. I'm just going to select another revision here, and then 34% I'm just going to say to yellow. and then that's going to be the thing. And now what you see now is that the traffic is now split here into blue, green, and canary. That's what you see here on the screen as well. So I'm just going to show this here, and then if you go this, pull this here, just going to traffic distribution as well, and all your traffic is now getting distributed to blue, green, and canary. um, So if the pod goes or zero, a new request comes in, then the pod will create and serve the request. That's right. That's exactly right. And Knative does it super fast motion because like it's pretty quicker. I'm going to show you that demo as well in a second. Let's say I'm going to create another service for that scaling demo. So I'm just going to say KN is a service client. As I told you all this time, I was showing you creating from the URL. Right now, I'm showing you to create from the command line. I'm just creating another hello world kind of a thing that's going to come from command line. And by default, Knative is built to serve 100 requests per pod. What I'm doing right now is that I'm going to set it to 1 so that I can show the scaling example as Moshin was asking me. So it's going to come up, and then it's kind of, it brings the pod so quickly that you hardly notice the difference. Still, if your application is going to be pathetically bad, then it still is going to have some kind of an issue when it comes up and serves a request. But in this case, like I have an application which is built up using binary mode, so which can start up pretty quickly so that it can serve your request quickly as well. So I need to wait for some time for this to come down so that I can burst the request to show you the example. So this is going to be the hello world thing which I have right now here. So what I'm going to do right now is let me pull this here so that I can show you the scaling up as well. So, but since I have a big cluster, there might be a delay in scaling up because the images has to be cached in all of the nodes, right? That's what we need to do here, and then that's what I'm going to do in a second. So let me make this bigger and allow this pod to scale down. So, but Moshin, to answer your question a little bit more precise, is that obviously, like we can also make the application faster, like choosing something like a Node.js or a Quarkus in a Java application case, make them using GraalVM compiled versions or something similar, so that like your application starts up pretty quickly and serve the request fast as well, right? You see this example. In this example, I made sure that this particular pod which I have right now, the service, the Quarkus hello world, can serve only one request. What I'm going to do right now is I'm just going to go and send it a big load, right? Big set of load to this particular one, right? So hey is a tool which you can use to send load request. Okay. What this is going to basically do right now is going to go and fire 175 concurrent requests. Since the Knative service which you deployed right now can handle only one request, it's going to spin up 175 plus pods to start to go serving the request. All right. So since I'm not cached the images, there might be some delay, but you can imagine that the speed, just to measure the speed of Knative. So you will see this. If you see the pod is getting spun up right now, I'm going to 240 pods in less than 10 seconds. Okay, and all this container getting created. Since the images are not cached, obviously it's going to cache and serve the request. But at the end of the day, if you see the command line, it has got the response back already. Okay. There was a slight delay in DNS lookup, obviously because I'm running on a Google Cloud in a different region. There is a fair bit of delay in the request call that's spent around DNS lookup. But end of the day, if you see it's got back the response in somewhere 4 seconds, right? 4 to 5 seconds, because it has to go cache these things as well, because some amount of things added because of DNS lookup. All right. But end of the day, what I want to tell you is that the speed at which it's spun up the pod right now, and it also be little bit proactive that it's added few more pods, so that like it can serve the sudden spike when it comes up in some time later. Okay. Is that make sense to you, Motion? And the beauty of this thing is, again, so since we have done with all the load and load requests, now what happens, the requests are going to go out, and then it's kind of going to go terminate as well. All right. So, but one thing what you have done right now is that I have given a request here to go and call this particular service, right? But what I can also do is, like, instead of me giving a request, let me go and get the other pods here. So let me go to the eventing one. I'm going to take this one up a little bit bigger. Uh, Make the size. Okay, fit it well. All right. So what I'm going to do right now, let me go here to eventing. Let me show you a quick example. The last example before I sign off is on eventing here. I'm just going to say that and then create an eventing thing, right? I'm going to do a cron job. I just say create here, and I'm going to put an event source. There are a bunch of event source right now here: API server source, container server source, cron job, and ping source. Ping source is what I'm going to take an example of. I'm just going to click on ping source, and then I need to fill up some parameters. And then I'm going to go up, grab some parameters from the CLI thing which I used earlier. Just going, I need to send a JSON data end of the day. So I'm just going to go here and send the JSON data right there. Copy there, and then schedule. I'm just going to give a 2-minute scale so that I can show you that the pod can scale down and come up again. Okay, so this, in this case, an external event coming from a source, an external event source potentially, in this case is a cron job, that's going to go and invoke, fire an event, and that event is going to invoke your Knative service. That's what is going to happen here. So and this I'm going to go and then tie it to a Knative service, so that service comes up, serves a request, and goes down. All right, so and just click it right now, and then you'll see this relationship up here. Let me zoom this a little bit down so that I can go up. The screen, and you see this the event which is happening right now. This service is tied up to this. I can even put it to Kafka and other stuff if you want to have more events, or AMQ brokers for that matters, to get an external event into the system. And that's what I've done here. So in this case, like, it's just going to be a cron job. This cron job is going to wake this service up, this particular service. Let's go to this pod, and deployment. There's no pods here. Let's wait for the pod to come. Once the pod comes, what happens, we'll go and watch the logs of the pod. In this example, I basically log the event which comes inside. The events are based upon cloud events. So you can just go to https cloudevents.io to go and read the cloud event stuff here, and then you can go and read about the specifications. That's what the CNCF standard that's been followed by Knative to share the data, the event data, between multiple services or even with multiple clouds as well. Okay, and then this is what you have done. So probably, like, I have pretty much done with my session, Prakash. I think maybe I give a couple of minutes more to show the scaling comes up, or else I have 3 minutes, which can give it back and probably take some questions as well.
Yes, Kamish. So I think we can wait for about 3 minutes and see if there are any more questions, and then we can start wrapping this up.
Sure, I think this should, by that time, this event should also come up, because the cron is scheduled to run every 2 minutes. Okay, you'll also see the eventing pod coming up, serving the request as well.
Yeah, sure.
So Tara, I think this is basically the OpenShift console, the OpenShift 4 console, which is built in by default with all these things to do. So you don't need to rely on the CLI. But I'm a CLI fan, but I want to show this one as well, so that, like, it shows you how easy to get this thing running. You see this? Now it got the event right now. When I click on this pod and go to the logs, I should see the log showing you the this message. Thank you for attending my sessions thing, which just came from all the thing that is C dash or cloud event headers, which got translated, and then I just printed them on the log. Maybe I need to blow this up to show you this one. Okay, and this is what happens when the message gets in, and you can process the message, send it to another service, or do whatever you want. All right. And then I also have this one as well, and then we'll wait for some more time. Now what happens, once the service is done with this job, it's going to go down and then go back to its dormant state as well. Okay, so let's go here. So I'm coming back to the question. So Manohar, I think there's two different. I think again, the good question on this, Manohar, like, is function as a service is very different. Is one of the ways by which we do serverless. Okay, it's not. I don't agree that function as a service is the only way of doing serverless. It's one of the ways by which we do serverless. And right now, what I've shown you is Knative is kind of a platform which can give you to run any workload in a serverless fashion. Okay, meaning to say, like, I still have service, but I call this as app resource optimization, which means that I'm going to optimize the resource that is being consumed by my application only when it's needed, right? Scaled and built for demand, exactly. Okay, that's what Knative does. So they can be used together 100%. It depends upon your use case. If you want to just run as a function, you can still run as a function as a Knative service as well. There are some specification which is getting worked out to add these function related features to Knative as well. Yes, they can be used together. You can use this monolithic microservice, function as a service, everything can be put together. So, Randir, I think that is totally different. That is Tecton pipelines, which can be linked with Argo to kind of do CI/CD, a kind of a scenario. In this case, it's more like, in fact, for a matter like I can even trigger an Argo CD event, kind of to go and trigger a service to run for us, right? So that could also be done. So there are numerous cases which can be built on top of this. All right. I think Prakash, that's pretty much I've done. I think I shared the slides already on the thing. I think there's a bunch of resources section on the slides, which gives you a lot of resources to go on, hang on to, a lot of tutorials like do it yourself kind of stuff. These are do it yourself tutorials, which meant to teach only the basics. Okay, and this is what is going to be done here as well, right?
Yes. Thank you so much, Kamish. Yeah, we definitely learned a lot about Knative. And since this was an intro talk, I think all the basics were covered pretty well. Uh, yeah, so now that we've come to the end of this meetup, I would like to take a moment to thank everyone who was involved in this meetup. First of all, I would like to thank Nuran and Kamish. You've been wonderful speakers. Thank you so much for joining us here on a Saturday afternoon and just sharing your gyan with us. Right. Also, I would like to thank everyone who attended this event and engaged with the speakers in the comment section, asked your questions, provided your opinions. Thank you so much for being here. Also, we do this meetup every month, right? And generally, we used to do theme-based meetups, but we are experimenting meetups without a theme. So, in case you have a talk that you would like to submit for one of our upcoming meetups, you can get in touch with one of us, either on Twitter or on Slack. I'll just put up the banners. So we are on Twitter. This is our Twitter handle. You can tweet to us. So yeah, so that's about talks, and also you can definitely engage more in the comment section, and in case you're hiring or anything, you can just post it over there. Use the comment section to reach out to your fellow Meetup community members, and yes, also one more point that I would like to touch upon is that in case you have any discussions, if you would like to discuss anything with the speakers, you can engage with them on Twitter or on Slack. And also, if in case apart from discussion, if you have criticism, I would suggest you resort to constructive criticism so that it makes the experience better for all of us, right? So with that, I think we've come to the end of this July Kubernetes meetup. Thank you so much, everyone, for joining us, and we'll be signing off right about now. See you. Bye-bye.
Thanks everyone. Thanks Suraj, and thanks Prakash. Thanks Nuren. Talk to you later. Bye.
Yep. Bye bye.